Hello everyone, welcome to today's class. We'll be continuing with the topic of vectors, and today we are going to do dot product, one of the most significant topic of vectors. Basically dot and cross product, these are the key points regarding vectors. Okay, let's start with it. Okay, so first of all, dot product, what does that mean? First of all, it is represented by A vector, B vector, and there is a dot between them. Okay, and it opens like this: mod A, mod B, cos theta. Okay, mod A, mod B, cos theta, where theta is angle between A vector and B vector. Okay, so let's say you have two vectors now, like this, A vector and B vector. Okay. And there is an angle between them, theta. So the dot product is magnitude of A, magnitude of B into cos theta. Okay. Second, if let's say your A dot B is 0, okay, then we can say either A vector magnitude is 0 or B vector magnitude is 0. Okay, or A magnitude is 0 means it's a 0 vector, so I can directly say that either A will be 0 or B will be 0. So rather writing like this, I'll write it in a reverse order, like if A vector equal to 0 or B vector is equal to 0. Okay, then A dot B is 0. Okay, now let's talk about some property. One of the important property is regarding the commutative nature. Whether you do A dot B or you do B dot A, they are both equivalent. Okay, so this is commutative property. Okay. Sometimes they can ask you about this in the form of language, whether dot product is commutative or not. So yes, it's commutative. Okay. We can use distributive property also, like A dot B plus C, it is equal to A dot B plus A dot C. Means we can distribute the dot product regarding plus or minus. Okay, I'm not saying just plus, it can be about minus also. So this is distributive property. Next, how do we actually do the dot product? Let's talk about that now. Let's say your A vector is A1i, A2j, A3k. Your B vector is B1i, B2j, B3k. Okay, so A dot B, how do we deal with this? Basically we multiply I with I, j with j, k with k. It's just that we remove the sign of I, because see, I dot I will become 1. I'll talk about that in a minute. So it is A1 B1, remove the I, A2 B2, remove the j, A3 B3. So you just multiply numbers. So basically if you look at this, A dot B, this is giving what? A1 B1, A2 B2, A3 B3. This is some sort of number. So we can say that A dot B gives a scalar quantity. This is important formula. Next is your A dot B is a scalar quantity. We just understood how this is. Okay. Next, let's talk about application, that is regarding projection. Okay. Projection of A vector on B vector. Okay. So it's given by A dot B upon magnitude of B. Okay. Similarly, if they talk about projection of B on A, then you do the reverse, B dot A upon magnitude of A. Okay. So I'll not giving you two formulas for that. One formula is more than sufficient here. Okay. All right. Then one more property is A dot A dot A is magnitude of A whole square, and we'll use this in forward as well as reverse. The moment we see mod A square, we can write A into A. Okay. Next, we'll talk about your I dot I. Okay, so I dot I, let's first understand. So if I do I dot I, sorry, I cap dot I cap. Okay, so basically it's a vector along x-axis. This is also a vector along x-axis. So both have the magnitude 1. So magnitude of I cap into cos. What is the angle between two vectors which are along the same direction? What is the theta here? 0 degree. Because this is I cap. So theta is 0, cos 0. What is now magnitude of I is 1. Magnitude of I is 1. 1 into cos 0 is also 1. So effectively I dot I, J dot J, K dot K is equal to 1. Now let's do I dot J. Okay. J dot K, K dot I. Okay. Again, the order doesn't matter because it's commutative in nature. So whether I'm writing K dot I or I dot K, both mean same thing. So let's try to understand how this value comes. Sorry. I dot J. So magnitude of I, magnitude of J into cos of the angle between them. Now how is I and J? I is along x-axis, J is along y-axis. The angle between x and y-axis is 90 degrees. So cos 90. What is cos 90? 0. So 0 into anything is 0. So rest all of this, I dot J, J dot K, K dot I, this is 0. So one important thing, sorry, one important thing to take from this, if the angle between the two vectors is 90 degree, means if the two vectors are perpendicular, the dot product is 0. So condition of perpendicular lines. What is the condition of perpendicular vectors or perpendicular lines? Remember we talked about condition of parallel lines in starting first lecture of vectors. Okay, now is the condition for perpendicular lines. Perpendicular vectors or lines as such. So this is A dot B. Two vectors are perpendicular if A dot B is 0. So if A dot B is 0, we'll say the vectors are perpendicular. If vectors are perpendicular, the dot product should be 0. That's the whole point. we can use it to find angle between the vectors also. Okay, to find angle between two vectors. How can we find the angle between two vectors? Let's say A dot B is mod A mod B cos theta. If I want to generate theta, I'll have to take mod A mod B on the other side. If you take it to the other side, what do you get? A dot B upon mod A mod B, that's cos theta. This is the formula to get the value of theta. Basically, of course, we'll get the value of theta by taking the cos inverse of this quantity, but this formula is more than sufficient to find angle between two vectors. And don't try to learn it too much. Basically, this is derived from the definition of dot product itself, mod A mod B cos theta. So if you forget this, try to generate cos theta and calculate theta from the two vectors. Okay, done. This is all the information that you need regarding dot product. We have talked about perpendicular, parallel. The result is scalar. If A or B is a zero vector, any of it, zero vector, then the dot product is zero. Also, we've seen that the two vectors are perpendicular, then also the dot product is zero. Okay, it's commutative in nature, it's distributive in nature. The dot product is calculated by multiplying I with I, j with j, k with k, remove I, j, k and add them. Okay, projection we talked about. That's it. All right. Now let's look at some formulas. Sorry, let's look at some examples now. Vectors. We'll start with simple questions, then we'll increase the level as we progress. Okay, there are a lot of questions on dot product. All right, first question. Find the angle between two vectors whose magnitudes are given to you, and dot product is also given to you. So it's a good thing, everything is given. So directly use the formula. What is the formula? Cos theta is equal to A dot B upon mod A mod B. What is A dot B? Root 6. What's our magnitude of A? Root 3 into 2. So this becomes cos theta as root 3 root 2. This becomes root 2 by 2, which is 1 by root 2. Cos theta is 1 by root 2. Theta is pi by 4. So angle between the two vectors is pi by 4. Okay. Simple enough. Let's look at the next question. Find the angle between the two vectors. Okay, this will teach you how to do the dot product also. So you have two vectors now. This is your A vector, let's say. This is your B vector. Okay. So let's write them. A vector is I minus 2j plus 3k. B vector is 3i minus 2j plus k. If you have already studied this in physics, this will be very simple. Okay. Because physics automatically uses this. I multiplied by I, j multiplied with j, k multiplied with k. Okay. Nothing is there, that means 1 is there. So 1 into 3, 3 plus 4, and this is plus 3. So what is the dot product coming? A dot B is coming 4 plus 3, 7 plus 3, 10. What is the magnitude of A? this is something that we discussed in the last lecture. How do we calculate the magnitude? Square root of, do each component square. What is the component here? I component is 1 square, j component is -2 square, k component is 3 square. Okay, so this is coming out to be square root of 1 plus 4 5 plus 4 sorry 9 plus 4 13 1 14. Similarly, calculate the magnitude of b vector. So square root of 3 square is 3 square plus -2 square plus 1 square, again same. Okay, anyway, so this is also coming to be 9 plus 4 13 plus 1 14. Okay. Anyhow, they are of same magnitude. Now let's calculate cos theta accordingly. Cos theta is a dot b upon mod a mod b. So a dot b is 10 upon root 14 root 14. So 10 upon 14. This comes out to be 5/7. So theta is equal to, we'll write cos inverse 5/7 and that's it. Okay. Plus 4 5 plus 9 14. Okay. So not necessarily every time you will be able to solve it. Sometimes you have to give your answer in terms of cos inverse. So cos theta is 5/7, so theta is cos inverse 5/7. Let's look at the next question. Projection of vectors. We did this. Projection of A and B. So he's saying find the projection of this vector on this. So this is your projection of A vector on B vector. So direct formula application. That's, so projection of A on B is A dot B upon mod B. So I'm going to do dot product directly now. So I multiplied with I means 1 minus 1 multiplied by 1, minus 1 into minus 1. Sorry, minus 1 into 1, 1. Magnitude of B is 1 square, so root 2. So it is coming out to be 0. 1 minus 1 is 0. No? So there is no projection of A on B. Okay. If you want to really understand what does the projection mean, it's like this. Like suppose you have a vector A on B. So the component of A, okay, if you know something regarding physics, you split the component of A, you write here it is A cos theta component, here it is A sin theta component. This A cos theta component is called the projection of A on B. Okay. So there is no projection, that means the vector is not at with some angle, not at acute angle with B, it must be at 90 degree. How can I say it's 90 degree? Because the dot product is coming 0. Okay. So they must be perpendicular to each other. Okay. Not every time you'll get the dot product to be 0, or sometimes you can get projection. Projection is some value. Okay. All right. Now let's see some other question. Let's look at this question first. Okay. He's saying find a x vector if A vector is given like this. This question was in the exam. I've seen that. If you go through the previous year, you'll find this question exactly in the exam. So again, this is from NCERT although, but same question was with the same values also, I think. So x minus a, x plus a, you have to do the dot product. Now I'll tell you how to open the dot product first. Okay, here you will not be I'll give you one shortcut also, that is also applicable, but I'll show you how it is working. Okay, Now in order to do the multiplication, we'll use the distributive property. Means we'll do dot product of x with x, x with a, then we'll do dot product of minus x with minus a with x, minus a with a. Okay, so it becomes x dot x plus x dot a, then minus a dot x, then minus a dot a. Okay, is equal to 12. The question say a is a unit vector, that means magnitude of a is 1. Now what is x dot x from the property? What? Okay, first do this. What is a dot a? Mod a square from the property. What is x dot x? Mod x square. Now you already know that x dot a dot x, they are same thing. Why? Because from the property it's clear that a dot b is same as b dot a. So I can change this to x dot a, and the moment I change this, this is negative, this is positive, this cancels. So what I'm left with is only x mod x square plus mod a square. Mod x square, I think we have to calculate that, mod x. So mod x square, magnitude of a we already know it's 1, is 12. So mod x square is 13. So what is your mod x? Mod x is root 13. Don't write plus minus because magnitude cannot be negative. The amount of something cannot be negative. You can have 1 apple, you can have 2 apple, you cannot have minus 1 apple. Okay, so magnitude of anything cannot be negative, so don't write plus minus 13 here. Okay, now the direct thing was you can literally use algebra also, but the point is with dot product it works, with cross product it doesn't. When we'll do the cross product you'll understand. That's why I'm saying if you want to be absolutely safe, go with this, but if you are comfortable with the manipulation, remember that the algebraic properties will work in dot, not in cross. Okay, so what is this? Is looking like a plus b, sorry, a minus b, a plus b, na? A minus b, a plus b. What is a minus b, a plus b? A square minus b square. Look at this, x square means mod x square and b is mod a square. So directly also you can do, but this is the proper approach. Okay, the restriction is this algebraic properties will work only in dot product, not in cross. So yes, I could have written it directly also, but I've shown you the basic working, how it is working. All right, now that we have done this, next time I'm going to use it directly. I'm not going to open it. Okay, so look at this question now. So magnitude of a, magnitude of b, you have to find if a plus b dot a minus b is 8. Now this time I'm not going to open it with multiplying each and everything. We know we can apply the property, but only in dot product. So mod a square minus mod b square is 8. Now it's already suggesting that mod a is 8 times mod b. So this is 8 times mod b square minus mod b square is equal to 8. Okay, so 8 square is 64 minus 1, 63 mod b square is 8. Mod b square is 8 by 63, weird value. Anyway, mod b is square root of 8 by 63. You can slightly simplify, I think, 2 root 2, and this becomes 3 root 7. So 2 root 2, 3 root 7, like this. That's it. This is magnitude of b. Magnitude of a is 8 times of this. So 8 into 2, 16 directly I'll write. 16 root 2 by 3 root 7. Okay. They could have given us a simple value. They would have given us 3, na? So 3 square was 9, 9 minus 1, 8, 8, 8 would cancel. You get good values of b then. Okay, but yeah, this value, if they have given us this value, we'll solve it accordingly. All right, this is done, this is done. Now let's look at few questions. next upcoming few questions. Let's look at this. He's saying A vector, B vector, C vector is given to you. He's saying A plus lambda times B vector is perpendicular to C. Find lambda. Okay. So he has mentioned the condition of perpendicular. The moment we see perpendicular, what do we know? We know that the dot product is going to be 0. So let's first of all find this A plus lambda B vector. So A vector plus lambda times B vector. Now how do we multiply any vector with lambda? You multiply each component with lambda. So basically 2i plus 2j plus 3k, that's A vector, plus lambda times minus I plus 2j plus k. Okay, so this becomes 2 minus lambda I, 2 plus 2 lambda j, and 3 plus lambda k. I have added I with I, j with j, k with k. Okay. Now you have a C vector. C vector is already given, 3i plus j. No k is mentioned, that means 0k. If you want to, you can write 0k or you can skip it also, your call. Let's do the dot product now. A plus lambda times B vector dot C vector. So how do we do the dot? I with I, j with j, k with k. So this becomes, multiply this, 6 minus 3 lambda, multiply this, plus 2 lambda, 0 with anything is 0. And the dot product, as mentioned that the two vectors are perpendicular, the dot product should be 0 because of perpendicular vectors. Let's solve it. Now this becomes 8 minus lambda is equal to 0. Lambda is coming 8. Good answer. Means the value is actually not in fraction. Okay. So I hope this is clear now. Now another type of question that comes is this. And this question, the kind of manipulation that it uses, not too difficult. It's just that the properties are being used and the approach is slightly unique. One type of question done like this, you will be able to understand the upcoming question and the methods. So far all the questions were directly on dot product. This time the question says A vector plus B vector plus C vector is a null vector, 0 vector. Find A dot B, B dot C, C dot A. Addition is given, dot product is asked. The values are not given, only information is that they are unit vectors. That means magnitude of A is equal to magnitude of B is equal to magnitude of C, that's 1. Now how can we calculate this? Only if we knew the angle between them, then mod A mod B cos theta could have been applied, mod B mod C cos theta, mod C mod A cos theta. But we don't know the angle between A, B and C vectors. So what we are going to use? We'll apply the magnitude property. A plus B plus C vector is a 0 vector, so the magnitude is 0. I can square it also, square it both sides. Now use the property of mod A square can be written as A dot A. Okay. So I'll write this magnitude whole square as the vector A plus B plus C dot with the same vector A plus B plus C. Now why I'm writing this, you'll understand, is equal to 0. Now this is like A plus B plus C whole square. Okay, A plus B plus C into A plus B plus C, A plus B whole square. I told you that the algebraic properties work only with dot product, so we can use it. Although if you literally want to do this properly, you'll have to go through the proper manner. A multiplied with A dot A dot B, A dot C, B dot A, B dot B, B dot C, C dot A, C dot B, C dot C. That will take a lot of time, so speed is good. So what is the property? A square. So we don't write A square, we write mod A square, because there is no such thing as A square doesn't mean anything. So magnitude of A square means something. B square means magnitude of B square. C square means magnitude of C square. 2AB can be possible. 2AB means 2A dot B, 2B dot C. 2 C dot A, that's 0. Okay, this much we know. Magnitude is 1 1 1, so 3 into 2 times. I can take 2 common from all of these expressions, so 2 A dot B, B dot C, C dot A equal to 0. So A dot B, B dot C, C dot A becomes how much? Take 3 on the other side, minus 3 upon 2, and that's the answer. So we generated the dot product using this property in reverse. A dot A A dot A is mod A square, or they use the reverse way. Mod A square is A dot A. Okay. All right. This is done. Let's look at this question. It's saying there are 3 vertices of the triangle. You have to find angle ABC, and their coordinates are given in 3D. Okay. The coordinates are A is 1, 2, 3, B is minus 1, 0, 0, C is 0, 1, 2. In order to find the angle, this angle, we need this vector, BA vector basically, and we need BC vector. Now BA vector, I told you that this BA vector, we discussed this again in the previous lecture, okay, that BA vector is actually A vector minus B vector. You have to do the reverse. Now how do we write A vector? You introduce ijk with it. Okay, so basically 1i plus 2j plus 3k minus this B vector is minus 1i plus 0j plus 0k. You subtract them. So it becomes 2i plus 2j plus 3k. Okay. Similarly, you can write BC vector also. Now BC vector is C vector minus B vector. Okay. So C vector is 0i plus 1j plus 2k. Okay. Minus B vector is minus 1i 0j 0k. Subtract them. So this becomes 1i plus 1j plus 2k. Now you have the two vectors and you need to find angle between them, the theta. What is the formula? The cos theta will be your dot product of the vector. Okay, A dot B upon mod A mod B. So this time instead of A, what is our vector? BA vector dot BC vector, dot product of them divided by their magnitude. Okay. So dot product of them, so 2 with 2, 2 plus 2 with 2, sorry 2 plus 1, 2 plus 3 into 2, 6 upon magnitude of A, this BA vector, 2 square, 2 square, 3 square. So square root of 4, 4, 8, 8 plus 9, 17. Okay. Similarly, magnitude of this is root 1, 1 and 4, 6. So 6, 4, 10 by root 102, 60 and 42, yeah. So theta is basically cos inverse 10 upon square root of 102. Okay. Anyway, the approach is much more important here, that first of all, if the vertices are given, you are supposed to create the vector through it. Okay. In order to create the vector, remember the coordinate, you introduce ijk with it, and then BA vector is A vector minus B vector. As simple as that. All right. There was one question. 1 second. This question, I'll write it. If again a vector plus b vector plus c vector is 0, okay, and this time magnitude of a vector is 5, magnitude of b vector is 6, okay, and magnitude of c vector is 9, okay, is saying find angle between a vector and b vector. Now remember from the last time what we did was we took the magnitude of this a plus b plus c is 0 vector, so magnitude is 0, squared it, so we generated a dot b, b dot c, c dot a. This time we don't want that, we only want a dot b. Why? Because in order to find the angle between a vector and b vector, what do we really need? The dot product and their magnitude. Magnitude we already have, okay, we already have the magnitude a and b. We only need the dot product a dot b. So in order to do that, what I'll do, the first step is we want a and b to be together and take c on the other side, and now take their magnitude. So magnitude makes everything positive, so remove it, remove the negative sign, then square it, okay. So this time what I'm going to do is use the property of same thing. I'll write first of all this as a plus b vector into a plus b vector, and this is magnitude of c square, basically negative square is positive. Now I'm going to use the property of a square plus b square plus 2ab, but a square means mod a square, b square means mod b square, 2ab means 2a dot b. And now I'm going to put the values. Mod c square, a square is 5 square 25 plus b square is 36 plus 2a dot b is mod c square is 9 square 81. So 2a dot b is 81 minus 36, 41, 61. So basically your 20 is a dot b. So a dot b is 10. Okay. I think after that it is pretty easy to find now that theta is the angle between them. So cos theta is a dot b by mod a mod b. Dot product is 10. Magnitude of a was 5 and 6. Okay, so 5 and 6. So cos theta is coming 2 by 6, 1 by 3. Theta is coming cos inverse 1 by 3. Okay. So you see the use of that property, na? Magnitude of a square is a dot a. This is how they can manipulate this. Okay. They can change the values accordingly. They can give you new questions based on this. Okay. All right. I think that's pretty much it about dot product. We'll start with the cross product in the next class. Okay, that's it from my end. See you in the next class. Good day, everyone.